Okay, here are the worked examples for 8.2. So for numbers 1 to 3, we're going to check to see if each of the conditions is met for calculating a confidence interval. And remember, this is checking to see if it's random, is it normal, and is it independent. So let's go through each of these carefully. Rating school food, LaToya wants to estimate what proportion of seniors at her boarding school like the cafeteria food. She interviews a SRS of 50 of the 175 seniors living in her dorm. She thinks that she'll find that 14 think the cafeteria food is good. Or she finds that 14 of the cafeteria is good. Okay, so let's go through this. Is it random? Yes, there was a simple random sample of 50 seniors. Okay, is it normal? So this is where you're checking for your NP conditions. Does n times p greater than or equal to 10 or n times 1 minus p hat greater than or equal to 10? And after doing the math, I found the p hat by taking 14 and dividing that by 50 because 14 of them thought the food was good and there were 50 that were surveyed. That gave me a p hat of 0.28. So 50 times 0.28, that gave me 14. 50 times 0.72, which is 1 minus 0.28, that gave me 36. Since both of those are greater than or equal to 10, the normal condition has been met. Let's go to our last one. Our last condition is independent. When we do the independence for this one, it's 10 times, remember we want to see if that it's at least 10% of the population. So 10 times 50 is 500. This condition here was not met because there were only 175 seniors living in her dormitory. So this one failed on the independence. Question number 2. High tuition costs. Glenn wonders what proportion of students at his school think that the tuition is too high. He interviews a simple random sample of 50 of the 2,400 students at his college. 38 of those interviewed think that tuition is too high. So again, random, simple random sample of 50. Notice I underline that. And as I'm reading these, there's information I am underlining. P hat I already calculated because it was 38 of the 50 that were interviewed, so I know that my p hat is 0.76. So checking the normal condition, so I did n times p hat greater than or equal to 10, n times 1 minus p hat greater than or equal to 10. So this time it's 50 times 0.76, and that gave me 38. 50 times 0.24, since 1 minus 0.76 is 0.24, equals 12. Since both of those are greater than or equal to 10, it checks. Let's check for independence. One college student has nothing to do with another. They're independent there, but let's see if we met the population condition. 50 times 500. Since we know that there were at least 2,400 students at the school, as stated in the problem, this condition also checks. So this condition is met as well. Question number 3. Fast driving. In a recent study done by the National Highway Council, it was found that in a sample of 2,673 young drivers, and young drivers was defined as 16 to 19-year-olds, 0.2% reported driving faster than 80 miles per hour. We want the proportion, P, in the population who drive fast, so random. It wasn't stated. We don't know how the sample was obtained, so we're going to proceed with caution. We're going to check normal. I did n times p. Now remember, I took this 2% here, this 0.02%, and I changed that to the decimal. Okay, so please remember, this is a common mistake made on the AP test, where students will take that and just put 0.2, but then that's 20%, not 0.2%. So the proper decimal is 0.002, and that equaled 5. So already I have failed. I don't need to do the other side. I can't apply normal approximation to this based on this. And if I can't apply normal approximation, what does that mean? It means I can't use z-scores. Question number 4. The small round holes you often see in seashells were drilled by other creatures. Whelks often drill into mussels, but this behavior appears to be more or less common in different locations. Research collected whelk eggs from the coast of Oregon, raised the whelks in a lab, and then put each whelk in a container with some delicious mussels. Only 9 of the 98 whelks drilled into the mussels. The researchers want to estimate the proportion of Oregon whelks that will spontaneously drill into mussels. So this one's going to be our first example of the 4-step process. So I'm starting with the plan, random, not stated, so unsure how they were collected. We're going to proceed with caution. If it does not tell you it's random, we can't assume it was. All we can do is state that it wasn't stated, and we're proceeding with caution. Normal, so I checked the normal. Again, n times p greater than or equal to 10. 80 times 0.092. How did I get 0.092? 9 out of 98. From here, only 9 of the 98. That became my p hat here. Okay. And since this doesn't equal 10, we don't meet the normal approximation again. Okay, practice. We want to find the z-score for 98% confidence interval using table A. So I'm going to split screen, well, I wish I knew how to split screen this, but I'm going to show you how to find this on your z-score table, just to be sure that everybody knows how to do it. Okay. So, find the z-crit score for 98% confidence interval using table A. So, remember, we find things from the left side. So, I have to find out what the left side is going to be. So, I do 100 minus 98, which gives me 2%. Changed it to a decimal and divided it by 2. That's going to give me, I'm going to do a really bad job, but I'm going to try to draw this. So, remember, what we're trying to do here is find at the 98% confidence interval, which means I'm going to have some percentage left in my tails. So I need to add this to this to get the 98%. That's why we divided in 2. We divided in 2 to account for this side and this side. That's a really bad picture. Okay, so it's a little bit better. So I have 0.01% here and 0.01% here. Okay, so that gives me a z-score of 0.99. That's what I'm looking up in my table. So I'm looking up in the table 2.33. So let me pull this up, make this go to full screen, see if I can't zoom it in a little bit better. So I'm looking for 0.99. So 0.99 is closest to right here. Okay, so that's 2.33. That one's right here. Okay, another way to do this, which I haven't really shown in the calculator yet, is to do inverse norm. Inverse norm in your calculator will find your z-scores. So here's my calculator. I'm going to go to second vars and see where it says inverse norm. Now, I did the 0.98 plus 0.01. You still have to do that math, and I'm putting in 0.99. And that gives me a z-score of approximately 2.33 if I round that to the second decimal place. So using the calculator, I was able to find the same z-score that I found in my table. Okay, so that's my z-crit value. That's 2.33. So let's find the 93% confidence. So again, I'm going to use the calculator. Let's see, I'm going to do 1 minus 0.93, which gives me 0.07, and I need to divide that in 2 in order to get both sides of that tail. So when I add 0.035 to 0.93, that'll give me 0.965. That's what I'm looking for in the inside of the table. So again, that number was 0.965, so I'm looking 0.965 is in between here and here, 1.0, yeah, it's really close to 0.181. Let's see what I get if I use my inverse norm in my calculator. So second vars, inverse norm, we had 0.965, and that gave me 0.181. So very close to what I found using the z-score table. Okay. So 0.181. Again, you can see where I visually drew the picture for you so you could see it. So that is the z-crit score I would use for a 93% confidence interval. Number 7, going to prom. Tanya wants to estimate what proportion of seniors in her school plan to attend the prom. She interviews a simple random sample of 50 of the 750 seniors, and she finds that 36 plan to go to prom. That's a large number of seniors. To give you an idea of how big that high school would be, that's almost if you add our junior and senior class together as one class, just to give you kind of that's a big school. All right, so we want to identify the population and parameter of interest. Okay, so population, and what is our parameter of interest? What is it we're looking for? So our population is the seniors at Tanya's high school, and the parameter, what is it we're trying to measure? It's the true proportion who plan to attend prom. So now we want to check for conditions for the confidence interval. So this is the plan piece. I put this in bold so you'd know. This is basically asking you to conduct the plan part of a 4-step process. So we have a simple random sample of 50. Normal, we're checking our conditions. Now, p hat. So I've over here I did 36 because 36 of them said they planned on going to prom of the 50. Okay, so that's how I got the p hat of 36 for 50, which gives me a decimal when I put it in my calculator, or a proportion of 0.72. So I did n, which is 50 times 0.72. That gave me 36. And then over here I did n times 1 minus p. 1 minus 0.72 is 0.28, so 50 times 0.28 is 14. Both of these conditions are met, so we can use normal approximation, which means z-scores. Independent. 50 times 10 is 500, and there were 750 seniors, therefore the 10% condition has been met. Okay, so all of this says that we can move on to doing the one sample z-test, or z-confidence. So construct a 90% confidence interval for P. Show your method. So this is the do part. So the first thing I have to do is find my z-crit score. So I have 100 minus 90, which gave me 10, divided by 2, which gave me 5. So I took 5 and added it to 90. That gave me 0.95. If you look on your z-score table for 0.95, that's going to fall right in between. It falls very evenly between 1.64 and 1.645, which is why you're going to get this 1.645, because it's right in between those. Again, if I were to use the calculator and do the inverse norm, so second vars inverse norm 0.95, it gives me 1.645 if I round this to the third decimal place. Okay, my p hat was 0.72. We already found that in the do part, or in the plan part. So then I'm putting it into the formula of p hat plus or minus z crit, that's our z-score, times the square root of p hat times 1 minus p hat over n. Okay, so putting those numbers in. So I have 0.72, that's the p hat over here. Okay, that's our p hat that we found right here. Plus or minus the 1.645, which we found is our z crit over here, times the square root of 0.72 times 0.28 divided by 50. Now when I did the math for this piece here, I will do the math for inside this first. Okay, so I put in my calculator 0.72 times 0.28 divided by 50. Here, I'll show you how I do this. So I'll do 0.72 times 0.28. I'll hit enter. I will immediately divide that by whatever my sample size was, and then I'll just take the square root of that answer. And that's how I got 0.0635. Then I can do the math for the rest of it as well, which gave me 0.72 plus or minus 0.1045. Okay, and then when I do the plus minus, I get 0.6155.8245. So that's our do part. All of this is the do part, and yes, you have to show all of it. The conclusion for this, interpret in context, this is the conclusion, is we are 90% confident that the interval from 0.62 to 0.82 captures the true proportion of seniors who plan to attend prom. Okay, online teen profiles have an online profile mainly on Facebook. A random sample of 487 teens with profiles found that 385 include photos of themselves. Construct a 95% confidence interval for P. This is what most of your questions are going to look like. So, automatically state, plan, do, conclude. Construct and interpret, confidence interval, state, plan, do, conclude. So we want to estimate the actual proportion of all teens who have a photo of themselves on their online profiles at the 95% confidence level. We're basically just repeating the question. Okay, so the plan, we're going to state which plan we're going to do. We're doing a one sample Z interval. Random, so this is where we go through random, normal, independent. So is it random? It stated that there was a random sample of 487 teens. Now I'm finding my p hat. So 385 of the 487, which gave me a proportion of 0.79. Is it normal? So n times p hat, 487 times 0.79 is 384. That's well more than 10. And then I have n times 1 minus p, so 1 minus 0.79 is 0.21. Times 487 gave me 102.27. Both of these conditions are met. So now is it independent? So 10 times 487 gave me 4,870, and I'm fairly certain it's safe to say that there are more than 4,870 teens in the U.S. So here's the do part. So we have p hat plus or minus a z crit times p hat 1 minus p hat over n, all that square rooted. Again, I'm going to go find my z-score. So 1 minus 0.95, so I'm going to have 1 minus 0.95, which gives me 0.5. Divide that by 2, because I've got to do the two tails, plus the 0.95. Now I'm looking for an area of 0.975. I'm going to go to inverse norm just so I have practice doing it, 0.975, and I get 1.96, 1.955. Okay, so that is using the inverse norm. You could have also found it using your z-score table, which would have given you the exact same value. Okay, so now plugging it into the information, so I have 0.79 plus 1.96. Here again, I have the standard error, so 0.79 times 0.21, hit enter, divide that by the total number, 487, take the square root of that answer. I'm not even going to type all that in because it's just too long, and there's my 0.0184 that I got. Then I can multiply that by 1.96. That gave me the plus minus on the right, and I can then do the math, do 0.79 plus 0.0362, and then 0.79 minus 0.362. I honestly recommend doing the minus before you do the addition, only so that your subtraction piece, the smallest number, will go first and your larger number will go second. You'll see them either way, but I just usually do subtraction first. Okay, and then of course I have to do a conclusion because a problem would not be complete without a conclusion. And my conclusion for this is we are 95% confident that the interval from 0.754 to 0.826 captures the true proportion of teens who have online profiles that include photo of themselves. Is it plausible that the true proportion of American teens with profiles who have posted photos of themselves is 0.75? So we found here 0.754 and 0.826. Is 0.75 in this? And the answer to that is no. It is below what we found. So yes, we would be surprised because 0.75 is not in our 95% confidence interval. And this concludes 8.2 proportions.